All right, class. Wow, come on, you guys are better yesterday. Class. All right, good job. All right, that's better. All right, so we are doing notes today. Today is 3/18. Okay, and these notes right here we're going to have are hashtag 11. Hashtag 11, and today's date. There we go. 1/15/20. Now, I'm having you guys date it every time. I don't know if you guys noticed that. It's going to help you guys do the table of contents, which a lot of people still never got those points for. Anyway. All right, yesterday we did imaginary numbers, right? The square root of any number that's negative is imaginary. Okay? So, anytime that I'm going to have this negative when I'm solving for my variable. So if I paid attention yesterday, how would I get rid of my square? Square root both sides, right? So if I were to square root both sides, that would be the square root. It'd be plus or minus square root of negative 367. And having that be negative means that that is imaginary. If it is imaginary, it is not real. So it's just asking, real or not real? All right, on the second one, if I were to try and solve for x here, I would want to get x by itself, right? So what would I do? Subtract the 25 first, right? Subtract 25, and then I would square root. So is that going to be real or imaginary? It's really imaginary? Okay, let me do the, yes, it is going to be imaginary. Let me do the work. So it's w squared is equal to negative 25, right? Because we're subtracting 25 from both sides. And when I take the square root like this, it's going to be a square root of negative 25, which is imaginary. So I say that this is not real. Not real. This one right here. To get rid of my square, I would square root both sides, right? So when I square root this, what's the square root of 0? 0. Is that going to be negative? No, it's not. Am I going to have a negative square root? No. So is this real or imaginary? That's real. All right, this one right here. To undo the square, I would square root. So that means this is going to be not real. All right. Let's see. Right here. And right here, it says Rafa was using the quadratic formula to solve x squared minus 12x plus 41. He wrote this. Notice that the number inside the square root's negative, said this equation doesn't have any solutions. Do we agree? Can we have a negative inside? Yeah. Didn't we just do that a minute ago for not real? Yes. Yeah, they're not real. So when I ever have a negative inside, it would be not real, which is imaginary. So we would say no, right? No. Okay, so we can, so we have imaginary numbers, right? All right, and this one is kind of like what we did yesterday. That negative right there, that negative, it's going to come outside the radical. And what am I going to write that outside the radical? I. So that's going to give me I square root of 20. And if we were somewhat awake yesterday, does 20 factor? Say yes. What times what gives me 20? 10 and 2. Is there anything else? 4 and 5. Why do I want to use 4 and 5? 4 is a, not even, perfect square. 4 is a perfect square. 4 is a perfect square. That's the reason why I want to use it. So 4 is a perfect square. So I'm going to rewrite this. So it's going to be I square root of 4 times square root of 5. So 4 times 5 is still that 20. It's still the 20. But square root of 4 gives me 2, doesn't it? Okay, square root of 4 gives me 2. So right here, this is going to give me 2i square root of 5. All right, and for some people that are struggling with that, you know, perfect squares and the multiplication and the factoring, you guys all should have picked up this thing today. Yes, it is a times table. All the perfect squares are right there down the middle. So 4 times 4, 16. So 16 is a perfect square of 4. So you find the number you're looking for, and that's how you find your factors. So if I want to find 30, I know that's going to be a 6 and 5. Now, is there any other 30s? Way over here, there's another 30. That's going to be 15 and 2. Okay, and we have 10 and 3, right? So this is going to help you do your factoring when we're actually going through and doing a lot of this, because you have to know common factors. So this is the inside of the back cover. This is the inside of the back cover of your notebook. All right, let's go down to number 3 here. Solve this equation and plot the solutions in the complex plane. Our graphing calculator does not plot in the complex plane. So what we're going to do first is we're going to solve this. We're going to solve this right here. So let's go ahead and use quadratic formula. I'm going to write out the quadratic formula, and we're going to use that. So we get like this. Let me see. It's going to be A is 3, B is negative 10, C is 50. So I would like you people right now starting to do that. Okay, so I'm going to start going over this. So hopefully you guys actually got to a good point here. So negative parentheses negative 10 plus or minus square root of negative 10 squared minus 4 times 3 times 50 all over 2 times 3. So positive 10 plus or minus square root of, so when I do this right here, it should be, what's that, negative 500?
Yep.
All over 6. So that's going to give me, so if I factor this piece right here also, what factors of 500 do I want to use? 100 times 5. 100 is a perfect square. And then the negative is going to be my I. So it's going to be 10 plus or minus. So I will take that out. So let me do it piece by piece. I square root of 100 times square root of 5 all over 6, right? So rewrite again. So 10 plus or minus. And that's going to be 10i square root of 5 all over 6. What's square root of 100? What is it?
10.
It's 10, isn't it? And that's why it became that. Okay, so now from here, I'm going to break it apart into 2 separate pieces. So in my separate pieces, it's going to be 10 over 6 plus 10i square root of 5 over 6. And then it's going to be 10 over 6 minus 10i square root of 5 over 6. Now, in the complex form of a graph, it's always a plus bi. So it's kind of like road directions. All right, 10 over 6. What does that give me? What's that as a decimal? It's almost 2, right? Is that 1.6? So it's 1.6. So this is a positive 1.6. So it's positive 1.6, 1.6. So it goes that way. And this is also positive, isn't it? Okay. So it's going to go, this is again 1.6, but times square root of 5. Because I don't know that one off the top of my head.
3.3.
3.3? Okay, so for you people still struggling with this, it was 10 over and then square root. I couldn't bring up my regular. Dang it. There it is. Square root of 5. So 3.7. Yeah. So it comes out to be 3.7i. So that's positive, right? So in a y direction, positive would be up, wouldn't it? So it's 3.7i. So 1, 2, 3.7i is right about here. So there's one of my answers. And the same thing for the other one down here. So it's going this way, right? 10 over 6. And then in the negative direction, it's going down the same thing. 3 point. There we go. So let's, right there. So on the complex point, it's just directions. So it's not very easy. It's something that we did a long time ago. Back in like November, December. Anyway, quadratic formula is your friend. Okay, make sure you like, share, and subscribe. Hit that notification button. Follow me on MySpace at, yeah. Anyway, yeah. We're going to use the rest of this time to finish up your homework. Let me see. Today is 1.6. 1.6 to do today, or 3.6.